um, covenants for the regular, and then the price alones for the VIP, as well as price alones for the regular. And then I should ask, do you want me to like click into each one of these to like,
No.
okay,
Just click, just after you, just click on the assign module. I want to see that one.
okay. So we did the T now for the arrival time, and did the exact same thing for the regular customer as well.
Okay. I also had asked you to create the, oh, I see. Now you don't need that anymore because you have two different
Yeah, and that was, and I originally did it that way, where I created the for the
process
yeah for the
time.
yeah, but then I was again having troubles figuring out how to resplit um, each type of consumer if I was to drag this
Mm-hmm.
and connect it just in
Yeah.
one single line when it spit it out here at the end before I did the
Mm-hmm.
record.
Yeah.
We hadn't learned how
Yeah.
to do that yet, which would
No.
made
No.
it kind of confusing. So which
Yeah.
is why I separated it like this.
Yeah. And in these operations, like you click, for example, on the price, the loans VIP. No, okay, and then click on the lower one too. The lower one, price, yeah. Okay, so that's fine. So what you have done here, you have used the same resource for these two operations, so that makes it a little better. I'll explain that in a little bit. So go forward, just continue. So then you did the record.
Yes, did the record, did the for the time interval for the VIP customer. I'm sorry, yeah, the arrival time, um, and then did the count for VIP customers, and I did the essential or the exact same thing for the regular customers as well.
Mhm.
I'm sorry, what did you say, ma'am?
No. I was just okay. Okay,
Okay,
and then at the end they exit the system.
yes.
Okay. Um, that's okay. So we could potentially, I mean, I think the ideal scenario is that we don't want to repeat our processes two times, right?
Yes.
So we want to be able to repeat, because if it's right now, okay, our processes are just four, but if there are very many, we don't want to repeat all of them for each customers. So we want to be able to, after we assign these attributes to the customers at the start, we want to send all of them to one line to get processes for the credit check, for all the pricing loans and so forth. And then they go to different, again, branches based on the so that we record the statistics for different customers separately. And we can potentially use that, still do that using the attributes, but you haven't learned that part yet. So I could potentially, when the customers come in and I know that they are VIP, they go to the 20% VIP, I can give a tag to them. And in this tag, for example, I can put value of 1, meaning VIP, and I can use value of 2, yeah, on the assign part. So no, you don't need to do it now, but here in the assign, I also could assign a tag. I could say customer type, for example. And then if the tag is if the tag has value of 1, it means VIP. If the tag has value of 2, it means it's a regular customer. And then we send them through just one line for the rest of the processes. They don't
Okay.
read everything. And then when they read, just before the record, if I want to send the VIPs to one record and then the regular customers to another record, then at that point I can use another decision node. And if you click on
Mm,
at the start, click on, yeah, just click on the decision node. I want to just see it. So you see on the very right, it says two-way by chance. If you open it, it also has two-way by condition. We haven't learned that one yet. But if we would put that, I could define conditions to say,
mm,
for this specific entity type, send them to we record VIP statistics, and then for this specific entity type, send them to this specific, yeah, so if you put, for example, attribute, yeah, so here we can put condition and say that based on the value, look at the value of the attribute. If the entity has value of 1, send them to VIP record. If the entity has attribute value of 2, that means regular customer, send them to a regular customer record. Okay, we haven't learned that part. That's why you guys couldn't do that yet. But potentially, I just wanted to give you some idea that we could assign the time initially and then send them through the rest of the process, just one process, don't repeat everything twice. And then at the end, if you want to separate them again, we could put another decision module, but here instead of chance, we can condition. And the condition that we are going to use is the attribute that we gave them initially. We look at that attribute. Anyone who has the tag of 1 in the customer type attribute is VIP. We send them to the record module for the VIP, and anyone who has attribute value of 2 means that they are regular customer, and we send them to the attribute, to the module record, to the record module for regular customers, and then they get the records done and then they leave the system. Okay, so we could do that as well.
That makes a lot of sense.
Okay, yeah, we haven't learned all of this complexity. That's why we couldn't do it all. But that's fine. Thank you very much.
So just out of curiosity, Professor, then, so does how I have my process flow oriented right now, does it yield the same results as it would if I were to do it via the way that you just described?
Yeah, actually it does. It's just because you have used the same resource for VIP and regular customers. So if you had, let's say if it were for the VIP customers on the top, you had used a different resource.
I see.
You know?
But because we're using Doris for both VIP
exactly.
and regular, it makes sense.
Yeah, exactly. So these customers has to wait in the line as if the resource is jumping between VIP customers and the regular customers, as if these VIP customers and regular customers are waiting just in one line. Okay. So it's just basically the priority of these people in that line is just based on who arrived first. So you have a line for the VIP customers and you have a line for regular customers, but in the simulation, we know exactly who arrived when to that specific queue. So the resource, the same resource, is just jumping between these two lines based on who arrived first and then processes them.
Okay.
As if they were in the same, as if they were waiting on the very same line. Okay. So, but if you had used a different resource for the line on the top and a different resource for the line at the bottom, you would get totally different results.
Okay.
Okay. And
Professor?
Yeah.
Now that we are thinking of making it in a single line, now in this case, would it make a difference if the design module was placed prior to the pricing the loans, or is it still an issue if we do it that way, Professor?
For the assign module?
The design module, if we
yeah. So
right for the pricing the loan process, because now that the other processes are going to be in a single line, and after assign, all the customers are going to flow through the same checking credits and preparing covenants process. Would it make a difference?
So yeah, so you can actually put the assign module before the process. So what happens here, guys? Just pay attention. In the assign modules that we have here, can you click on the assign module? So we assign T now. Okay. So here, irrespective of what type of customers they are, I can assign T now. Okay. And then, so I could potentially have just no decide module and one assign module. Okay. Irrespective who comes to the system, I will just record their arrival time. okay? And then, so I could just have one assign module here. And I need to decide module before they get to the pricing loan section, because before they get to the pricing loan, I need to know who is VIP and who is regular so that I can give them different processing time. Okay, so I could potentially have just one assign module at the very start, and just give them the arrival time, no matter what type of customers they are, and go for everything through this one process, and then put a decide module right before pricing loan to find out 20% that are VIP and the other 80% that are normal, and then give them, and then you need to put another assign module. Okay, so let me then you need to put another assign module to give them the different processing times. So let me bring my iPad and draw that for you, because I think it's hard for the rest of the class to follow. We could start with the arrival. We had only one arrival, right? Sorry. So this is when we do the create. Okay. Right now, irrespective of who is the type of customer, I could do an assign. So this is assign module. So I could assign the Tina. Okay. And then everyone goes through operation 1, and then operation 2. Operation 3 is the pricing loan ones. Okay, and here the regular customers get a different processing times, and the VIP customers get a different processing times. So I could develop an assign module here and say that, okay, if you are VIP, if you are regular. If you are VIP, then I would assign their processing time. So this is assign. Okay, and here also, if you are regular, again, I would put another assign for process time. Okay, and then now I'm going to send them to the same operation 3, and then they go to operation 4, and then you would need to, if you were going to use the tag for customer time, then you need another assign module to give them the tag. So here you give them a tag. In addition to assign process, you also give them a tag based on the customer type. And then here you look at tag value, and then send them to their own record. And this is another record. And then they dispose. Okay, so this one is decide module, and we use condition to decide where should we send the VIP customers and where we should send the regular customers. And the condition is that we look at their tag values, and their tag values is the one that we already assigned here in this decide module, in this one. Okay, so what happens is that customers come, we give them an arrival time. So this is also assigned. So we give them an arrival time, no matter what type of customers they are. They go to operations 1, they go to operations 2, and right here, then I would differentiate them. I would say, okay, 20% of you guys are VIP and the other are regular. And then give them the processing time for operation 3, because each one of them has a different processing time for operation 3. At this point, I also give them a tag to just in the tag value for VIP customers. Let's say I give tag of 1. For regular customers, I give the tag value of 2. Okay, so I define a tag. I call it, let's say, customer type. Okay, so I give them, so at this point I give them 2 tags. One tag is the process time, and the second tag is customer type. For the process time, I put the processing time for the VIP and regular customers on the pricing loan operation. For the customer type tag, I give them a value of 1 or 2 if they are VIP or regular. And then they go to the pricing loan. Based on their value of the tag, each one of them will have a different processing time. And then they go to the last operation, distribution of the fund. And then here, I want to send them to different record modules, because for the VIP customers, I want to see how long they have been in the system. For regular customers, I want to see how long they have been in the system. So at this point, again, if I want to distribute them again, I'm not going to use again another 20%, another 80%, because it may send the customers, it may send the VIP customers to a regular category or regular customers to a VIP category. So I'm not going to use another 20%, 80% chance again. Here at this second decision module, I'm going to make the decision not by chance, but by the condition, which we haven't learned yet. And in this condition that I'm going to put in this decision module, I'm going to look at the value of their tag. If their value of their tag is 1, that means they're VIP. If the value of the tag is 2, that means they're regular customers. So I send them to the right record module. Okay. So, so that's the right way to do it, so that you don't need to repeat things so many times. The way that Christian has done it right now is working too, and is actually correct. The only thing about it is that the processes here, the process 1 or process 2 and process 3 and 4, they have been repeated twice. And for this problem, because we only have 4 processes, this works, it's okay. But if we had long processes, so many processes, it would be very time consuming and also computationally expensive for the simulation to repeat all the processes twice. Yeah, that's the best way, I think the most efficient way to do it. But you guys didn't know that this is decide by the condition, so if you have repeated the processes twice, that's fine too.
Professor, will that be better if we have a decide function just right after the arrival function, and we can have the VIP, where we can actually assign all the same just after that?
Yeah, you could do that as well. So that would be similar to the one that Christian has done. So you could.
No. Can I share my screen? I actually just did it in your way, but I just moved the assign function a little bit forward, decide function a little bit forward. This is my model. So here I moved the decide function a little bit forward, and those two are actually exactly the same. This one is actually by chance, and the last one is by condition, but I use 0 and 1. And if we assign the VIP and regular right after the arrival of the customer, we actually only need those two assigned once. We do not need the second one. I mean, because we already assigned everything here.
You have assigned the T now here, and then also the processing time here as well. Yeah, so you can do that as well, but that's again assuming that you know the decide by condition. that which you have done at the end. You could just put 2 assigned modules and then take care of that. Yeah, you can put your decide module at the start too. I'm just giving you different options of if you don't put the assign to the decide module at the start, you need 1 assigned module for assigning Tina, and then you let me share. Can you stop sharing? Instead, you want to put your decide module here, right? So here in this way, as you can see, we have used 3 assigned module. 1 here, the second one is here, the third one is here. Okay, if you put the decide module at the very start, so entities arrive, and then we have a decide module to decide what is the customer type. And then if they are VIP, I go this way. And then if they are regular, I go this way. Then I need only 2 assigned modules. In these assigned modules, I can assign T now, and then I can assign process time as well. Okay. And that's what Christian has done as well. However, and if you don't know how to use the decide by condition yet, you have to use 2 separate lines for the rest of the processes. Okay, but if you know how to use the decide module, then similar to what you have done, you are good to use just 1 line for the rest of the processes. And before they are sent to the records, you can definitely use another decide module to send them to the right processing, to the right record module based on their attribute value. So the advantage of this one is that you use just 2 assigned modules, and right at the start, and you assign the TINA, no matter what type of customers they are, and then you assign the processing time to them. However, I wanted to mention this as well so that you guys get a sense of some of the attributes, like the process, like the arrival time, that we can assign or we can specify at the start, no matter what type of customers they are. Yes, I want to calculate the time that they have spent in the system, but as long as at some point I differentiate between these 2 customers and send one of them one way and the other one another way, I can still calculate the time that they have been in the system for each one of them, because now I know this is for VIP customers, and this is for VIP customers, and this is for regular customers. So I can still calculate how long each one of them has been in the system, and I also know the time that they have entered the system. So still it works. So the reason I wanted to give you the first option is that you guys know sometimes, although we want to record attributes for different type of customers, still we don't need to put the decide module, because we want to calculate or record the T now no matter what type of customers they are. So we can just assign them T now no matter what type of customers they are at the start, and then at some point we can differentiate between them. For example, in this decide module, we can differentiate between them, give them a tag based on the type of customers, and here based on the value of the tag, I can send them to different records. Here in this method, we give them a different processing time and T now at the very start based on the decide module, and that's correct too. Okay, so you can do this problem based on different ways, but what I want to make sure is that you guys are clear about when is a good time to assign some attributes to these entities, and if it's necessary to have a decide module at that point or not. And for big models that sometimes may lead to, especially the computational cost, maybe sometimes using one approach and having more assigned modules, and as opposed to the other ones that uses just 1 or 2 decide module and so forth, can make a difference in terms of their processing times your simulation time, your simulation runtime. If your model is very, very big, then adding a couple of more modules can make a difference. But for the small modules, small models like us, it doesn't. But all that matters is that you guys know when is the right time to assign the attributes, and the fact that you can assign some of these attributes at different locations, and also when is a good time to use the decide module, and the fact that you can use the decide module again at different locations based on the attributes that you assign. Okay, I hope this is now a little more clear for you guys. So we are going to still work on the previous model that we developed, but we are going to add more functionalities to that one. So please create a folder for week 6, and then open the model we did in previous session and save it as in the folder for week 6. What did you put for the name of the model in previous session? What is the name of the models in previous session that you saved?
Is that for one model 4.1?
Okay, now we are going to do model 4.2. Okay, so save the model we did in previous, open the model we did in previous session, model 4.1, create a folder for week 6, save that model in the folder for week 6, and change the name for model 4.2.
Is the name still electronic assembly and test attribute?
Yeah. And so change the name to 4.2, and at the end of the name, delete the attributes and add schedules and failures. Can someone read the name of the model for me, please?
Model 4.2 electronics assembly and test - schedules and failures.
Exactly. And then save it in the folder for week 6, please. So if you remember when we ran the previous model, we saw that the rework operation was the one that the longest waiting line, and also the number of entities that so the number of entities that were waiting for the rework were long, and the time they were waiting in the queue was long too. So now we want to see, okay, what if we assign one more worker to this report? So we want to make some changes in our model. So the first one is that we are going to have 2 shifts. Okay, and then in shift 2 we have 2 workers for rework. Okay, so we are going to have 2 shifts. Each shift is 8 hours. We are going to have 2 shifts. Each shift is 8 hours. Okay. In shift 1, we have 1 resource for each operation, similar to what we have done already. In shift 2, in the second 8 hours, for the rework operation, we are going to have 2 workers. Okay. Then the sealer machine, the sealer machine is going to break down. Excellent. And what we know here for this breakdown is that machine uptime, meaning the time that is working, before it breaks down has exponential distribution, 120 minutes. Means that the process, the time that the machine is up and is working is about 2 hours, is about 120 minutes. And then when the machine breaks down and it goes down, it takes about time to repair. It takes about 4 minutes to process, to repair the machine and bring it back up. Okay, this is 4 minutes. So sealer machine breaks down. When the machine is up and running, it works for about 2 hours, 120 minutes. When the machine goes down, we need to perform the maintenance or whatever we need. And then that operation takes about 4 minutes and the machine is back up again running. And also, since we know that the rework operation is the one that has the longest line as well, we want to buy some racks for this to put before this operation, so that if we have just too many parts waiting, instead of just waiting in a long line, we can put them in this track. Okay, so we want to put these racks before the rework operation, and each rack holds 10 parts. Each rack holds 10 parts. So we want to put these racks before the rework operation, and each rack holds 10 parts. We want to know how many racks we have to buy to be able to reasonably hold the entities that are waiting before the machine, so that we can process them, so that they don't need to just sit on the ground or wait in a long line. Okay. And those are the changes we want to make in our model. Everyone is clear about the changes? Did you take the note? Okay. Let's go back to our model. Let me just stop. Did anyone ask any questions?
Yes, can you hear me?
Yes, go ahead.
For the racks that you said come before the rework station, do we have exactly 2 racks or?
No, that's what we want to find out.
Oh, okay.
We want to put racks, and we don't know how many racks we want.
So we're going to look at the queue length before rework.
Exactly. So we want to see how many. All we know is that each rack holds 10 parts, and we want to see how many potentially we have to buy.
Got it. Thank you.
So then let's go to see how we can potentially do this one. The first thing that we want to do is for the resource. Okay. For the resource, we want to, so remember we set the resource that we have at the rework. Now we have 2 resources. One, we have actually 2 shifts. In the shift 1, we have only 1 resource, and in shift 2, we have 2 resources for the rework. Okay, so let's see how we can potentially capture that one. Before we start anything, let's go to the run. Set up an hour per day for each one of them is going to be 16. So each day we have 2 shifts, each one of them has 8 hours. So hours per day, I want it to be 16 hours. So I want to run the model each day for 16 hours. And how long I'm going to run this for? I'm going to run it for 10 days. So for 1 time that I want to run this model, I'm going to run it so that I'm done with 10 days. And for each day, I'm going to run it for 16 hours. Okay. So make sure to change these changes in the setup. And the reason that we make these changes is that I want to implement that shift concept in the model. So if we make these changes, it would be easier for the model to capture the time and everything. So later we will learn other ways to change the run setup section so that we capture the 2 shifts and so forth. Right now, for the simplicity, just say that each day is just 16 hours because we have 2 shifts, each one 8 hours. And I want to run the model, let's say, for 10 days. Okay, so time unit is going to be days. And then you can still leave the time, the base time unit, which is the time unit that we will see in the model, as minutes. Okay, everyone is done with these changes? We are done, press OK. Okay. Now, we want to see how we can take care of the resource related to this one. Remember, the first change we want to make here is that, okay, we have 2 shifts, each shift has 8 hours, and then in shift 2, we have 2 workers for the rework operation. So we want to see how we can do that. Okay, so let's go to the resource. So for the rework, we want to take care of the part that the rework, it doesn't have fixed capacity anymore, meaning that if I leave it at fixed capacity of 1, it means that during the whole simulation time, I have 1 resource for the rework. But this is not the case anymore. So instead of fixed capacity, I'm going to define a schedule for this resource. And so as you can see, when I put the schedule, so these 2 columns are added, and the capacity one is idle because it's not fixed anymore. So now I have to define a schedule for this resource. So now potentially, so let's go back to the basic resource, and as you can basic process module, and as you can see here, I have a module that is called the schedule. Okay, so to click on the schedule module, and then this opens for you. Okay, so we want to define a schedule. And what is the schedules? Schedules are basically the modules that help us to capture planned availability for the resources. Here, the availability of the resources, if 1 is available or 2 is available, is planned. Like we know exactly for 8 hours, 1 is available, for the other 8 hours, 2 is available. So these availabilities are not random, they are planned. If you want to capture planned availability of the resources, we use schedules. Okay. So now for this one, let's, if you don't have a row, let's click here, double click to add a row. And then let's click on this one, and this window opens. So, okay. So what you wanna put as the name of this schedule, let's say we wanna call it rework schedule. Okay. And this schedule is for what? It can be for a bunch of things. For example, for arrival, we will actually have that in one example too. But for this one, we want to use this schedule for the capacity of our resources. Okay, so just leave it as capacity. Just to make sure everyone has this window open. Is there anyone who doesn't know how we got to this point? For the time unit of the schedule, let's keep it as hour, because we want to say for 8 hours, we have 1 resource, and for the second 8 hours, we have 2. So just leave the time unit as hours. Okay. And for the file name and things, we are not putting anything right now. For the duration, so let's click on the add, and this window opens. So it says, what is the value, or what is our capacity? So our capacity is 1 for how long? For the first 8 hours. Duration is 8, and the time unit is hours. We already know that part. So press OK. And then add another one. So for the second part that we want to add to our schedule, the value is, the capacity is 2. We have 2 of this resource. For how long? For another 8 hours. Okay. So press OK. If you are good, the rework, the name of the schedule is rework schedule, because it's a schedule for the rework. Is related to scheduling of the available capacity of a resource. The time units are hours, and then here you add the duration that you want to have different levels of capacity. For the first one, for the first 8 hours, we want to have 1 resource. Oops. For the first one, we want to have 1 resource for the first 8 hours, and then we want to have 2 resources for the second 8 hours, and then press OK. Okay. So now you see that this information is added here. The name of your schedule is here, is related to the capacity. The time unit that you want to use is hour. And here, as you can see, for the durations that you want to play with the available capacity, you have two rows. If you click on this one, this window opens. So if I click on the very last column, this window opens. And here also you can enter your values as well. So what I want to say here is that you could enter the information related to rework schedule in two ways. You could either click here at the very start, just click here, window opens and you enter everything here. If you don't want to enter everything in the window, you can just enter everything in this row. And at the end, if you want to now enter the information related to availability of your resources, you can just click on the last column and then this window opens, and here you can just add rows and just say, I have one for the first 8 hours, I have 2 resources for the second 8 hours, and if it continues, just add more rows to this and just add your schedule. Okay, so you can do that in 2 different ways. Make sure to save, guys, as we proceed so that you don't lose something. Okay, so now let's go back to our resources. So for the rework resource, which we said I don't have a fixed capacity and the available resource that I have is changing throughout the simulation, I want to define the availability based on a schedule that I already have defined here. So I pick based on the schedule, and then here you have to define the schedule name. Okay, since we already defined the schedule, the rework schedule is available here. So we can pick that part. Rework, I can. So the rework schedule is available here. So we already defined that. So it's here, we can define that. So the next thing that we want to specify is the schedule rule. And if you just click on that, you see you have 3 possible options: wait, ignore, preempt. Okay, I'll tell you in a second what each one of them means. Okay. Everyone is okay so far? All good? Okay, so let's see what these 3 rules for scheduling means. So as you saw, we have 3 options. One was ignore, one was wait, one was preempt. Okay, so these are the 3 options that we have to deal with our resources when our schedules kicks in. So let's see what is the ignore one. So let's assume this is the time access. Okay, so our resource is working, and let's assume this is 12 o'clock, and then this is 1 p.m. at noon, and this is also our let's say launch time or break time. Okay, we can also consider the launch time or break times using the schedule as well. If we say that, okay, during the launch time, these resources go to each launch and they are not available to work, we can also incorporate that into the model using the schedules as well, because that's the planned availability of resources. So let's assume this is our launch time. Okay, so let's assume our resource has started working here, okay, and it's working right now and is working all the way, okay, and the work hasn't finished yet. Okay, now the schedule kicks in. So based on what you have identified, the resource has to go to the launch time. Okay, and this resource is already working. This resource has started working. Let's see how we can deal with this situation in the simulation. So there is one option which is called the ignore. So right now we are doing the ignore option. The ignore option is that when the schedule kicks in at 12 and this resource should go for launch, we totally ignore that. So as if the launch time hasn't started. If the resource is busy with the work, we wait till the resource finishes the work. So the resource is going to finish the work. Let's say it takes another, I don't know, 15 minutes to finish the work. So the resource will finish the work, and then the break starts here. Okay, so basically break starts here. So the break starts here, and then the resource goes to the break and then comes back right at the end. So the resource comes back. The resource is available here again. Okay. So in other words, in the ignore policy, when the schedule kicks in at time 12, the schedule is ignored. And if the resource is working, the pink part, the resource will continue working till the operation, till the work is done. And let's say at 12:15, the operation is done. Okay, the resource goes to the launch time right at that time, and it's going to still come back at time 1. The resource was scheduled to take 1 hour launch time, but it's going to take 45 minutes launch time. Okay, so this is basically the new launch time or the break time. Okay, so that's the ignore. If that's the situation here, in dealing with the resources when a schedule or a time off kicks in, we use the ignore option. Okay, let's look at the other option. I wanna now capture the oops. Sorry, does that just... So now I want to capture the wait option. Okay, so what does that mean? So for this one, our resource is working at time 12. The resource needs to go to the launch, and at 1 p.m. the resource is supposed to come back. Okay, so that's the launch break. The resource is working right now, and then the break kicks, the launch time kicks in. Okay, so what happens in the wait option? The schedule doesn't start. It waits till the resource finishes the operation. When the resource finishes the operation, then the break starts here. And if let's say right now it's 12:15, break, the resource is going to continue for 1 hour. So the break, so let's say right now it's 1:15. So here the break ends here. Okay, so that's the wait option. So there's the resource is scheduled to take a break between 12 to 1. That's the launch time. However, at time 12, when the schedule kicks in and they want to take time off, they are busy with processing something. So their schedule doesn't start, their time off doesn't start. We wait till the resource is done with the work that they are doing. And as soon as they are done, then the schedule starts, and they still are going to take the full 1 hour time off, and they are going to be back to work, and the break basically ends at 1:15. If they start at 12:15, they start at 1:15. So they're back to work at 1:15. So that's the wait policy. Oops, that's the wait policy for the resource and the schedules. Okay, so we talk about the ignore policy. The ignore policy was that if they are busy, the schedule still starts at time 12, but they're busy with processing a customer. So basically, their break time starts as soon as they are done, and it ends right at 1 p.m. So this is their break time. So they take only 45 minutes break, although they were scheduled for 1 hour. But in the wait time, if they were scheduled for 1 hour, they take 1 hour break. You are good with that. Okay. So then the third policy is preempt. Okay. So let's see how this one is working. So let's say again, this is time and the resource is working, and this is 12 and this is 1 p.m. and this is their lunch time. And the resource is busy with processing a part or doing something, and then the schedule should start, their time off should start at lunchtime. Okay, so now what does preempt mean? It means that when the schedule started, it's fine. Just stop everything you were doing, start and then do your break time. If one of the resources is not available here, it's fine. Let them go. Let's take the time off, do the lunch time, do the break time. So this is basically break time or the time off or anything it is. And then after this time is over, then we are going to continue the rest of the operation. Okay, so this is the rest of the operation. Okay, so if we did maybe 20 minutes of that operations at the start and still 20 minutes is left or 15 minutes is left, we are going to continue the rest of the operation at the end of the launch time. Okay, so that's the preempt option. And if you want to know which one of them is the one that is working in a model that you are simulating, I would say first just take a close look at what is happening in that setting. Just go and check, okay, what happens when your resources need to take time off or their shift ends and things like that. So if the shift ends and you need to lose one of your resources, like what happens? Do they just leave like in the middle of the work, or no, they still have to wait and finish the work and then they go? What happens when the resources need to go to the lunch time or the break time? If they are in the middle of the work, should they wait and finish the work, or no, they can go get their lunch time or do the lunch time or break time and then come back and then continue the work? So just look at the rules and see which one of them is the one that is working, and then apply that one. However, there is a rule of thumb for this for also picking the right rule. So if we are modeling a setting in which the break time is short, so let's say for the break time, I'm going to show it with B, and then for the processing time, I'm going to show it with A, with P. Okay, so if the break time is shorter than the processing time, okay? So let's assume we are doing the processes, okay? So this is all our processing time. So we are doing the processes, and then we just want to give let's say 15-minute breaks to our workers, okay? So if the break time is a lot shorter than the processing times that the customers do, we usually use the wait time, because if I give, let's say, 15 minutes of break time to my workers, and they are busy with this processing times, and I just want to give them 15 minutes break time, I don't want to even cut these break times and use the ignore, because remember in the ignore we cut the break time. If the break time is 1 hour or lunch time is 1 hour and they are busy with something, they still have to finish the work and then take the break and still come back at 1. But in the wait policy, if they start taking a break at what time, 12:15, they come back at 1:15. So if the break time is shorter than the processing time, we usually use the wait options. And that makes sense as well, because as I told you, if the break time is short, it's like we want to give 15 minutes break time, and we don't want to cut anything of that. If the worker is busy at the time that they have to take a break, that's fine. They still have to wait and finish the work. However, when they are done and when they have finished their work, they are going to take a break, and they are going to still take the whole break and come back when the whole break time is done. Okay, so that's in those scenarios we usually use the wait option, because we don't want to cut those little break times that the resources have. We want them to use the whole break time. So in those scenarios we use the wait. However, if the break time is a lot larger than the processing time, so it's larger than that, then we are okay to maybe take a little bit of the break time as well, like this one. The break time was initially 1 hour, but then since the processing times, since operation times are really short, the resource, when the break time starts, the resource is still working. So we tell the resource, just continue your work for another couple of minutes if you have to do, and then take your break time. Okay, so the break time is is bigger than the processing time. So if the resource continues to finish the processing time, like here, so I just work a couple of more minutes to finish the processing time and then take the rest of the break, it's not going to be the big deal. Okay, so in those scenarios we can use the ignore policy. So if our break time is bigger than our processing time, we are okay to use the ignore policy. And for the scenarios like this one, the very last one, this is pretty trivial. So for a lot of industry problems, we use the preempt option, because even if you are in the middle of the work, most of the time it is okay to just pause everything, go eat your lunch, go take your 15 minutes break and whatever, and then come back and then continue the rest of the process. So for those, maybe preempt option works better. If you look at the problem that tells you explicitly that we are going to use ignore option or the wait options or the preempt option, okay, put that in there. If they describe something in the problem statement that helps you to find if it's ignore or wait or the preempt, read that description carefully as well. If none of them is there, then look at the processing time and the wait time and see what is the relation between them. And also in the real world scenarios, as I said, take a closer look, ask questions like, if the resource is working and then suddenly lunchtime starts, and then lunchtime starts, then what is the policy? What do we do here? And get more information to see which one of these policies is the one that works better for you. Is this clear, guys? I'm going to stop sharing the iPad page. Did you take the note? Everything is good? Okay, so let's go back to our model. For this problem, for the rework schedule, we want to pick the ignore. Oops.
Professor, I have a question. So is this rule only affects when like the resource is actually taken away but not added? Like if we switch it from 1 to 2, it just immediately join the resources, right?
Yeah, even for each scenarios, so we want to make the change in the number of resources that are available. And if the current resource is already busy doing something,
yes,
introduce it. We just want to let the work finish.
Yeah.
Make the changes and then.
Oh, okay.
Okay.
Got it. Thank you.
Sure. So for this one, pick the ignore and save. And also let me add as well, if the resource that you have is a bottleneck in your system, so you don't have enough resources, picking the right rule is going to make a difference in your results. If the resource is not a bottleneck and things like that, so maybe changing the rules is not affecting that much. But if the resource is a bottleneck in your system, you don't have enough resources, then different rules can change your results. Just keep that in mind as okay. So that's with the resource and as with the schedule. So schedule is used to capture planned variation in the availability of the models. Okay. If I know for the first 8 hours I have one resource available, and for the second 8 hours I have two resources available, these are planned. These are the things I know. I use the schedule to capture planned variation in the availability of the model. And let me also add one more thing as well. When we use the schedules and things for the resources, simulation behind the scene captures 4 different states for the resources. So, and what are these resources? Let me write them. What are those states? So let me write them here so that you guys are familiar. So behind the scene, simulation can have 4 different states. So we use idle, and when a resource is idle, means it's not busy. So nothing has been assigned to the resource to work on. So the resource is available, the worker is available, but is not busy with processing any entity. And then we have busy. Busy means that one entity has seized the resource. So the resource is busy with processing that entity. So at the time when they are idle, that means no entity has seized the resource. When they are busy, it means one entity has seized the resource. So the resource is busy working on that entity. And then the other one is inactive. When a resource is inactive, means that it's not available to work. Okay, so you already have 2 workers, but one of them is not available to work in the first 8 hours. So for the first 8 hours, that resource is inactive. Okay, and then the last one, the last option that we have is failed. If you have a resource, but they have failed, and you have a resource, they are available to work, but they have failed and they cannot work, we consider that as a fail option. And we are actually going to learn how to capture the failures in our resources in a bit. So when we define resources, when we assign schedules or failures to them, behind the scene simulation captures these 4 states for our resource. If they are idle, meaning that they are available to work, but no entity is seizing them. When they are busy, means they are available to work, an entity has seized them. Inactive means they are not available to work, and failed means they are available to work, but they have failed. Okay, so they keep that in mind as well for these 4 possible options. Now let's go to the failure part. So we said one of the things that we want to capture in our model is that the sealer machine breaks down. The time that the machine is up is 120 minutes, and the time that they have to be repaired is 4 minutes. So how we can capture that part? So first of all, make sure to save your model, guys, so that you don't lose anything. So the sealer operation here, the resource that we have, the one resource that we have is not available all the time. They may fail as well. So we want to capture the failure. Okay. So let's go to the resource again. So again, we have 2 options for capturing the failures associated with the sealer resource. So let's do the first part. So we have a failure module in the system. The failure module, the failure data module, is not available in the basic process, it's available in the advanced process. Okay, so click on the advanced process tab if you have it. If you don't have it, can you tell me how you can bring it? We talked about that in the first session. You go to the file, template panel, attach, and then here you have advanced process. So pick that template and then open. You will see that advanced process, a template panel will open for you. Okay, so in this one, we wanna use the failure module. Everyone is good so far? So let's click on let's double click here on the failure module. So click on the failure data module, it opens. So double click till one row is added. And then double click till the window opens. Okay.
Professor, how did you get the row to show again?
Just double click. If you double click here, a row is created.
I see, thank you.
Sure. Okay, so double click and then this window opens. Okay. So our failure, let's call it sealer failure. Okay, so for the failure, let's call it sealer failure because we want to specify the failure associated with the sealer. And for the type, peak time. Okay, what does time mean? Time is the scenario that we have right now. Means that we know the uptime. We know in the uptime the machine is working for exponential 120 minutes, and then the downtime, when it goes down, it takes 4 minutes to get the repair and comes back up. Okay, so these are the when we pick the time option, that's what it means. If I pick the count, what does that mean? Count is the scenario when we tell the simulation that the resource at this operation is going to continue till we process a specific number of items. In the manufacturing process, actually, sometimes the count is used more. For example, if I say that this machine has to process 100 parts before I change the tools. This machine has processed, let's say, 150 parts before I perform the cleaning operation on the machine. This machine has to perform 150 parts before I perform the specific adjustment of the machine for the rest of the processes. So all of these are considered as failure as well. Change of the tool, the adjustments, the cleaning part. So they are, although they are not like quote unquote failure, but they are considered as failure as well. And for those, we can use the count, meaning that we tell the simulation that this failure happens after we process a specific number of entities. That's what we specify in the count. Okay, and then when they go down for the change of the tool or for the cleaning time or for the adjustment time, how long that time would take. It takes 10 minutes. Maybe if we change the tool, we specify that as here as well. So those are the scenarios for which we pick the count. But here, this is not the case for us. The downtimes and the uptimes are specified based on the time. So for the uptime, we have exponential. So our uptime is 120 minutes. So they work for about 120 minutes exponentially distributed. Then they go down, and when they go down for 4 minutes till we perform the maintenance operations and so forth. And then they come back up again. So make sure to pick the time, make sure to change the time units to minutes, and make sure to put the right values for the uptime and downtime. Exponential 120 minutes and exponential 4 minutes. Okay, and here also we have, here you see the column uptime in the state only. What does that mean? So we are not going to change it right now. If I don't put anything, that means no matter what happens in 120 minutes, that's considered as your uptime. Even if the worker or the machine takes a break in between. Something happens and no one is working with that machine. Those times are also considered in the 120 minutes. Okay, and then after that 120 minutes, no matter if it's working all of the 120 minutes or just part of it was the break time and lunch time and no one was working with that machines or so forth, we still consider all of those as that 120 minutes. However, if that 120 minutes is only when the machine is working, and when the machine is busy, we can specify those in the uptime in this state only. And we will learn later how to do that. We actually define a specific state for the entity, for the machine, sorry, for the resource. We specify specific states, busy, not busy, and so forth. And when we come here, we say that this 120 minutes is when the resource is busy. So consider, so if in the middle, the resource take a break, for whatever reason, the resource is not busy doing something, that's not going to be considered as the uptime, because we tell the simulation that 120 minutes is when the resource is busy processing something. So consider that as the uptime. For now, we are not going to put anything in the uptime in this state only, which means that we just consider 120 minutes, no matter what. If in the middle of this 120 minutes, the resource needs to go to the lunch or take a break, or for whatever reason, this machine is not working, that's fine. That's still considered as part of that 120 minutes. Okay, later we will learn how to use different states and tell the simulation that this 120 minutes is when the resource is busy processing something. But for now, just leave it as empty. Okay, press OK. So then you see all of these appear here as well. So like similar to what we did for the schedule. I could specify all of the things we specified in the window here, or we can do it in the window. You can just create and just say, pick the time or count. You get the right number of columns. You can specify the uptime, downtime. You can specify the time unit, minutes, and uptime in this state only. You can specify that as well. You can specify everything here, or just double click on this row and specify everything in this window. Both of them are fine. Make sure to save as we go forward. Okay, and then let's go back to the basic process template. Let's click on the resource for the sealer resource. So you see here failures. So click on that. So what I did, I came back to the resource module in the basic process. Okay, and now, because what I have done so far is that I have assigned a failure. Okay, and I have said, yes, this is what happens in this failure. The machine is up for 120 minutes and then it goes down for 4 minutes. But simulation doesn't know that that failure things that I define should be used by the sealer resource. Simulation doesn't know that. I just defined a failure. Simulation doesn't know that failure is for the sealer resource. So now I have to come back to the resource, pick the sealer resource, and tell the simulation that the sealer resource is the resource that is going to use that failure. So for when we pick the sealer resource, you see here we have a failure column. If you click on that column in the row for sealer, this window opens. And here, if you double click, a row opens for you. And then if you click on this failure name, the sealer failure that we define is here. Everyone is good? We already have defined a failure. So when I open the failure, and when I want to specify the failure that I'm going to use for the sealer resource, if I click on the failure name, I see the name of the failure that I already have defined. If you have multiple failure, you can obviously use those as well. So I pick the failure name, and then it asks about the rule. How do you want the rule to be? So for this one, if you remember here, I told you the machine is working 120 minutes and then it's going down only for 4 minutes. So the break time or the downtime is 4 minutes. It's a lot less than the processing time or the working time, which is 4 minutes. So in this scenario, I'm going to use the wait option, because remember I told you, if the amount of downtime is less than your processing time, use the wait option, meaning that if the part is being processed, let the processing to be done, finish the processing, and then the machine is going down for 4 minutes and finishes that 4 minutes, and then it goes up again. So in this scenario, if the resource is working, processing an entity, and then the schedule, the time, the schedule for going down kicks in. We finish the processing part, and then we go down for 4 minutes, and then we use all of that 4 minutes, and then we are back up again. So for the failure type, here use the wait. Okay. Again, if you are doing a real world scenario, just do some investigation. What happens when the failure happens? If the failure happens and the machine goes down no matter what, and then we fix the machine, and then the machine goes up and we finish the rest of the process, use the preempt. If that's the one that captures the real world in your problem more closely, use the preempt. But here, let's pick wait just for the, so that we all get the same results, and also based on the rules of thumb that the downtime or the break time is just 4 minutes, which is a lot less than the processing time, which is 120 minutes. In those scenarios, the wait option works better. And let's do that. Okay, so click close the failure, and as you can see here, it shows one row has been added, and you have that here as well. So make sure to save your model before we proceed, guys. Let me mention one more thing before we proceed. Remember here, for the rework, I define a schedule, and I'm using only for the resource rework. Let's here, as you saw here, for the sealer, I defined a failure, and I'm using that for the sealer only. However, if you have a schedule, and this schedule for the availability of your resource is used for other resources as well. Is used for the prep operation as well, is used for all other operations as well. You can do that as well. You can just define one schedule. I can still come here, and for this schedule, I can define one schedule. In that scenario, obviously, I'm not going to call it as the rework schedule. I'm just going to call it or shift schedule or things like that. You can define that schedule once, and you can use it for different resources. When you go to your resources, if more than one resource is using that schedule, you can do that as well. So you can do that as well. You can assign the resource to more, you can assign that one schedule that you define to more than one resource. So you don't need to define the same schedule for multiple resources several times, okay? You define one schedule only once, and you can assign it to different operations, different resources, if all of those resources are using the same schedule. What happens that when the simulation runs, simulation just assign those schedules to the resources different, okay? The same for failure. You can, if the failure for the prep operation, for prep resource is the same as the sealer one, you can do the same as well. We can go define only one failure. We can go to here, and when I go to the failure, obviously I'm not going to call it sealer failure anymore. I'm just going to call it a more general, so that I can use it for all the resources. I define the failure once. I say, okay, whatever resource is going to use this failure, uptime is always 120 minutes and downtime is always 4 minutes. And then when I go back to the resources here, when I go back to the resources, I can assign the same failure that I have defined only once to more than one resource, okay? If the prep A is using the same failure rule, if the prep B resource is using the same failure rule, I can assign that same failure to more than one resource. What happens in the simulation behind the scene, for each one of the simulations, for each one of these resources, different random numbers are generated to replicate that failure. It's not that the uptime, let's say for the uptime, if for prep A guy, we use the simulation generates 80 minutes because we say exponential 120, right? It can be anything about around 120. Let's say for prep A, the uptime is chosen randomly to be 80 minutes. That's for prep A. For prep B, although I'm using the same failure, another uptime is generated. Another random variable is generated for prep B, and another random variable is generated for the sealer. When they go down for the repair, and not one downtime is generated from exponential for the prep A, another downtime is generated for prep B, another downtime is generated for the seeder. Although I'm using the same one failure that I have defined, but simulation is generates different random numbers, each one of the operations that is using the same failure. So keep that in mind. If your resources use the same schedule, you can define just one schedule, use it for multiple resources. If your resources use similar failure mechanisms, you can define one failure only and use it for different resources. Okay, so let me just, before we go to the last part of the model, let me just summarize what I wanted to, what I have said so far. So we used a scheduled module to model planned variation in availability of resources. We knew that in the first 8 hours, one resource is available. In the second 8 hours, two resources is available. So those are planned variation in availability of the models. When we wanted to capture random variation in availability of the resources, we use failure module. Okay, we knew the resource is available for about 120 minutes, but we didn't know exactly. We knew the resource would go down for about 4 minutes, but we don't know exactly what would be the number of minutes that the next resource would go down for. So these are random variation in availability of resources, and to capture those, we use the failure module. Okay, so keep that in mind. And if you remember, we initially said that we want to make 4 changes in our model. So we already did the number 1, number 2, number 3. And the last thing we need to do is to find out in the rework operation how many racks we need to buy to be able to hold all the parts that are waiting before the rework operation. And what we know is that each rack holds 10 parts. So we have to somehow get some sense of the numbers of the availability of numbers of the numbers that number of items or entities that are waiting in the queue. Remember, when we run the simulation model, it automatically tells us average number of parts or items or entities that are waiting in the queue. So I know on average, for example, about maybe 20 parts are waiting in a queue for the rework, but that's just the average of all the number of parts that have been waiting in the queue during the simulation run. So that's not the number that I want right now to know exactly how many racks I want. So we need to be able to monitor the number of parts that are waiting in the entity, and over time, and we need to know how many times, for example, if I have observed 8 parts in the queue, how many times I have observed 8 parts. If it's too many parts, okay, then I may need to if it's too many times that I have observed 8 parts, then I may need just 1 rack. Like if I see, let's say 20 something parts, how many times I have observed that one? If it just has happened once, maybe I don't need to buy 3 racks and just what they stay empty for most of the times. Okay, so I just don't need to know that just knowing the number of parts that are waiting in the queue, average number of parts that are waiting in the queue for the whole simulation run is not enough. I need to know exactly how many parts have been waiting in the queue over the simulation run, and how many times I have observed, for example, 0 parts. How many times I have observed 1 part, how many times I have observed 2 parts, and so forth. And then look at those and then make a conclusion based on that. So as we go to do this, and when you see the results, you get a much better sense of what it means. Okay, so for that, basically what I want to do is to calculate a new statistics. Okay, so we want to calculate a new statistics. So be able to do that, we need to go to the advanced template again. There is a module here called advanced statistic. So it's called a statistic. Okay, so when you click here on the statistic module, this is what you see. If you double click here, a new row is created for you. So let's click on the static module, the first row, so that we can create what we want. Okay. So I'm going to call this rework stats. Okay, so that's the name of this new statistics that we are going to create. So It's related to number of parts in the rework queue, so I'm just going to call it rework queue stats, okay? And then what is the type? I remember in the past, I told you in previous session, I told you when we create a statistics, it can be maybe a time persistent or a tally or a counter. So we learn what each one of these terms mean and which one of the statistics fall in each category. We have here one more, which is in the frequency category, and frequency and output. So I'll show you in a second what does frequency mean. But for this one, let's pick frequency. Okay, so we pick frequency, and what we want to look at the frequency of the value and of the number of parts that are waiting in the queue. Okay, so keep the frequency type as the value, and for the type, pick the frequency. Okay, so rework queue stats, the type is frequency, and we want to look at the frequency of the value and what value, and we're going to specify that value in the expression. Okay, so here, instead of just writing something here, which is what we most of the times have done when we want to specify an expression, we are going to right click and just say build expression. Okay, and when we do that, this window opens, the build expression window. Okay, so what I want to specify here, I want to specify the value of number of entities that are waiting in the queue, okay, in the rework queue. So what should I do? Since this stats that I want to specify is related to a queue, let's click on the queue. Okay. So remember, one more time, to be able to bring up this expression builder window, we right click on the expression box here, we right click and then pick build expression, and then this expression builder one opens up. Since whatever I want to calculate, which is number of entities in the rework queue, is related to the queue, I'm going to pick queue. And here, as you can see, it allows us to pick a bunch of things that we can calculate for each queue. One of them is current number in the queue, okay? One of these average number in the queue, average wait time, average wait cost, and so forth. So here, what I want to calculate is current number of parts that are waiting in the queue, okay? So it says current number in the queue, so I pick that, okay? And then, as you can see here in the expression, it puts NQ parentheses part A prep queue. Okay, so NQ calculates the current number of entities in a queue. You can memorize this, or you can just not memorize, and every time you need to do that, just come here, you open the expression builder window and just say I want to get current number of parts in the queue, and the NQ is written for you automatically. However, remember, this NQ is not for the prep A queue, is for the rework queue. So here we go to the queue name here on the right side, and then we pick the rework process queue. And when we pick the rework process queue, another one is written for you here. So you can just delete the old one. NQ, you can just delete the old one and just keep the new one that was added. What we could do as well, if you pick the number of queue here and you just delete it in this parenthesis, and then if you pick any other queue, the name will be put for you in the middle. So it just puts NQ anyway. So pick the current, and then here we pick the rework queue, and then it puts number of queue in the rework queue, in the rework process queue. Okay, so if you pick the current and automatically it puts the NQ for the first queue for you, and then you pick the right queue, and then it repeats everything one more time. Just delete the extra time that it has been repeated. Okay, at the end, what I want is NQ, which is the current number in the queue for the rework process queue. Okay, so I want that. So make sure to do that and then press OK. Okay, so the expression is written here for you. If you knew that number of parts in the queue is shown by the NQ, and you knew the name of the queue that you want to calculate this for, you could just type this here and that would be fine as well. But you don't need to know what NQ or what number of parts in the queue is exactly. If you don't want, you don't need to necessarily memorize the name of each queue. So for that, you can just right click here, go to build expression, write whatever you want, just press OK, and whatever expression you have picked is going to be put here for you. Okay, and we want these numbers, number of parts in the queue, to be collected for the entire replication. Okay, so nothing else is active here. We don't need to put anything else. Here you see report label. This is the label that we see when we run the simulation. In the report that is generated, we see these stats with this label. And this label is automatically put equal to the name that we give to this stat. If you want to change it, that's fine. You can change it here. If you don't want, just leave it as is. Okay. So now we want to do one more thing for this stat that we want to define as well. When we look at the frequency, when we look at the number of parts in the queue, so we are going to say that, okay, put them in these categories. If you want to specify categories, you can do that. So here we are going to do this. We say that, okay, let's add one category. If this frequency, the number of parts in the queue that we see, is just 0, we are going to define this as a constant, and I'm going to give a name to this, and I'm going to just say 0 rack. Okay, so if the number of parts in the queue is 0, I'm going to define a fixed category, and I'm going to call this category as 0 rack, and this is just constant value of 0. I'm going to call it 0 rack, meaning that if the value of the number of parts in the queue is 0, I'm going to call this 0 rack category. Okay, and don't change anything else. This is a constant value of 0, and I'm just going to call this option as a 0 rack category, and then press OK. And then let's add another category. So now, if the value of the number of items or entities in the queue is more than 0, it's in a range. And what is the range? The range is going to go from 0 to 10. Okay? If it's going to go from 0 to 10, if I see the number of items in the queue go from 0 to 10, this means 1 rack is enough. So I'm going to call this category as 1 rack. Okay? And what does include means? When I put 0 to 10, include means if I put it 0 to 10, it's like this, 0 all the way to 10. That's what it means, which means starting from 0 to 10, I'm not going to include 0, but I'm going to include the high value, the 10. Okay? If you don't want the 10 to be included from this menu, you pick exclude. Okay? But here, we want the 10 to be included. So if the value of our frequency, if the number of parts in the queue goes from 0, not including 0, it goes from anything above 0, 1, all the way to 10, 10 included, I'm going to put it in a new category and I'm going to call this category as 1 rack. Okay? Make sure to the include is picked. Press OK. Let's define another category. In this category, I'm going to pick range again. The lower part is 10, however, 10 is not included. the high value is 20. 20 is included. And here I'm going to leave it as include. And if the range of the number of entities in the queue is between 10 to 20, I'm going to call this category as 2 rack. Okay, press OK. And I'm going to add the third one, just the last possible categories. I'm going to add 1. And again, I say this is a range. The lower value is 20. However, 20 is not included because if it is included in the previous category, it's not included in this one. Anything above 20 to 30, sorry, above 20 to 30, 30 is included. Then the name of this category, I'm going to call it as 3 rack. Okay, and make sure the include is picked as well. So I'm going to just pick these 4 categories: 0 rack, 1 rack, 2 rack, 3 rack, and for each one of them, I set this. I told the simulation when this rack should be picked, when the number of parts that are waiting in the queue is just 0, is between 0 to 10, between 10 to 20, and between 20 to 30. Okay, so specify all of that, and then we press OK. So all of those are specified here for you. Okay. So the rework name, the stat name is the rework queue stat. It's here. The type is, we want to calculate the frequency of the numbers that appear to be in the queue. And we want to calculate, so what is the expression? What do you want to calculate? These are the number of items or entities in the queue, the current number of entities in the queue. And we want to collect this statistic for the entire application. And we specified 4 categories that you can see here. So here, if I click on these columns, you see the 4 categories that we specified in this window. 5 categories. We see them in this window. Okay, so similar to other data modules, you can either create a row, click on the statistics, click and create a row here, and then click on this row, double click to enter everything on this window. If you don't want, you can specify here, you can specify everything in this row. Again, you can specify if it's frequency, if it's tally, whatever. You can specify anything on this row. And if you need to specify categories, you can just click on this last column. And here again, you can double click and add rows and specify what is the start value, what is the end value, what you want to name this category, and should it be include or exclude. Okay, make sure to save, guys. So that's the statistics we have identified for the number in the queue. So while we are here, let's double click and define another statistics as well. So this new statistics is for the sealer operation. So for this one, we want to specify the name as, so double click. If we want to specify it as sealer stats. And the sealer stats, again, we want it to be frequency, and you will see in a second why. And then here, we don't want to choose value, we want to use state. So for the sealer, we specified the up and down times. So simulation behind the scene automatically will put the sealer in the busy state, in the idle state, in the failure state, and so forth. And we want to see how many times this sealer has been in those states. So then for the frequency type, I don't pick the value similar to what we did for the rework queue. I pick a state. And then the simulation will tell me the frequency of how many times I have observed these states: busy, idle, failure, and so forth. Okay, and everything else is idle, as you can see, is gray, meaning that you can't pick anything else. And I want this to be collected for the entire replication. And that's all we want. We don't want to specify any other category or so forth. And the label of the report that we're going to see is going to be the sealer stat in the report. Here, this is going to be for the sealer. frequency, yeah. For the sealer stats, we are going to pick the frequency. We are going to see the frequency on the stat and on the states that have how many times it has been in the busy state, how many times in the idle state, and so forth. And then for the, I also need to pick the resource name that this is going to be for the sealer resource. And then for the entire population and everything else is fine, and we press OK. Okay. Make sure to save as we go forward. And now we are good to run the simulation. So, and we already know that we have set it to run for 10 days and each day is 16 hours. Okay, so let's run the simulation. And if you want your simulation to go faster, you can just click on the fast forward to go faster. So fast forward button here, you see at the top. You can click on that for your simulation to go fast. So again, we see how many entities have left the system during this simulation run. For each one of them, we can see the time, the cycle time, the value added time, the non-value added time, wait times, and so forth. We can see them for part A and part B, so since we have two entities. We can see the working process for each one of them. Number in, number out. We can see the information related to the processes, how long the processes take, the information related to the queue, how each one of the queues were busy and so forth. For example, if we go to the rework process queue, okay, you see here, previously when we ran the simulation, the rework process was the one, so the rework process was the one that has a really long time for the waiting, and still the long time is the wait time is long, but it's less than what we had seen before in the previous model, and the number waitings and so forth. Okay, and also we still see all the users specified that we had specified before. We can see them as well. What I want you guys to do here is to come to here. If your report template should be open here, right? You see the one here is the template, right? If you go to click on the frequencies, then this appears for you here as well. Also, if you can click here, you see the frequency, the two statistics that we define, the rework queue stats and the sealer stats. We can see them here. So here you see for the rework queue stat, we were going to calculate how many parts are on the queue. That's what NQ meant. But we were going to show the frequency of how many times we have observed those values. That's what the frequency means. So how many times I have observed zero number of parts in the queue. 32 times I observed zero number of parts in the queue. That's why the zero rack has been observed 32 times. We have had parts going to the queue and then leaving the queue and so forth. 32 times we observed zero part in the queue. How many times I have observed one rack, the category? Remember, one rack was for the scenario when I observed 0 to 10 number of parts in the queue. 0 is not included. Anything from 1 to 10 number of parts in the queue. That would fall in the category of one rack. And then how many times I have observed that? 33 times I have observed 1 to 10 number of parts in the queue. So that's why we see the frequency for the one rack to be 33. And how many times I have observed the two rack category, meaning that the number of parts in the queue have been between 10 to 20. 10 is not included, 20 is included. Only 2 times I have observed that. And so that's what the frequency means. I want you guys to understand this really quick. So as if I define these categories and then I plot a histogram on top of these categories, on top of these values. The 0 value, and then any value between 1 to 10, and then any value between 10 to 12. plot a histogram, I plot a bar chart on top of these three categories, and this is the height of these bar charts, 32, 33, and 2. So looking at this bar chart or histogram on top of these categories can tell us that we probably don't need to buy 2 racks, because only 2 times for the whole simulation time, for the whole 10 days, only 2 times I observed the number of parts in the queue to be something between 10 to 12, 10 to 20. And that 2 times only was 7 minutes of the whole 10 days for which I have run the simulation. Okay, so only 7 minutes. So probably I don't need to just pay a lot of money and buy 2 racks just to cover this scenario. And as you can see, we also, when we defined the stats, I also defined another category for 3 racks. Remember, I don't see the 3 racks here because it has never happened. So, so that gives you a sense that if you wanted to recommend something to the manager of this facility to how many racks to buy, probably I would recommend 1 rack, because that's usually, that would be enough to hold the items that are waiting before the rework. And I don't need to go to 2 racks. Definitely I don't need to go to 3 racks because it has never happened. And also for making that decision, also look at the cost of those racks as well. If they are very, very expensive, definitely I'm not going to buy this 2nd rack to be bought. If they're not really that expensive, maybe I would say, okay, buy 2 racks, you will be fine for sure, forever. So I would definitely recommend 1 rack. Okay, so that's what the frequency means. And it also tells you how many times these values have been observed. For 119 minutes, we have observed that 1 rack is enough. For 176 minutes, we have observed that we don't need any rack at all. For 7 minutes, we have observed that we need 2 racks, so we can ignore that as well. For the other stats that we defined, that we wanted to look at the frequency related to the states that the sealer resource can get, you see the simulation has these states automatically. I didn't define busy state or fail state or idle state. Simulation for each state that goes through the failure automatically adds these possible states. If the state is busy, if the state is idle, or if the state is failed. How many times I have observed the state is busy? 1,000 times. How many times I have observed this resource is failed? 93 times. And how many times I have observed this resource is idle, meaning that it's available, it has not failed, but it's not working? 1,000 times as well. And we see also the time that the state, this resource has spent in each one of these as well. Okay. And so again, that's frequency. Although I use states, that's frequency. So it's, again, when we pick frequency, it's like plotting a histogram on top of these 3 categories. The number of observations gives you the height of these columns or these bars are top of busy state, failed state, idle state. That's what frequency means. The number of observations for the rework queue tells us the height of the bar on top of 0 rack, 1 rack, 2 rack. If you don't know how many categories, like here, remember I added 3 categories, but how did I know I should stop at 3 categories? Maybe I need 4 racks or 5 racks as well. So usually I run the thing that can help you is that if you run the simulation once and just look at the average of the parts in the queue, that can give you a sense of how many racks you potentially may need. So if I see like the average number of parts in the queue is 20 or so, or is about 10 or so, or 20 or so, then I will put maybe 2 racks, and I may add also another 3 rack as well. But if the 3rd rack is not used, it will never be shown. But I never continue introducing 10 different categories. Maybe they show up. Okay, and also if I define, let's say, 3 categories or 4 categories, and then but the numbers I see are more than that, the simulation would show a row here out of category. You will see an out of category row. That means you need to define more categories for that statistics, because you see an out of category row here. That means the number of categories you defined wasn't enough. You actually have observed numbers that fall out of the categories that you have defined. So you can go back, define more categories, and run the simulation again and see how the numbers show. Okay, so basically that's what frequency means when we pick that as the type of the statistics that we want. If we don't put time persistent or tally or counter or anything, we put frequency, that's what it means. This is how the numbers are reported. And if you put value, this is what it means. If you put value, we have to specify the categories. If you put states, the simulation automatically knows this is a state, so we don't need to define any category. Okay? So that's what basically all this means. So we learned 3 things in this model. We learned how to use schedules to calculate shifts if our resources, for example, here rework resource are different numbers are available in different shifts. We can specify the schedule. We learn how to define a schedule and how to assign it to a resource. If our resources are going to not be available, but not based on a planned schedule, but based on unplanned schedules such as failures, we can define failure using the advanced process template. We can define failures, and then we can tell the simulation model how to use those. And then we can tell the simulation how to use those failures for which resource and how. And then we also learned that if we need to calculate some statistics related to number in the queue or a bunch of other things that we learn later, we can always come to the statistics data module and define new statistics. And we learned that this is statistics if they are not falling in the 3 categories that you learned in the previous session: time persistent, counter, and tally. They can be either frequency or output. Here we learned the frequency option, which can be for the values we observe or for the states we observe. Later we will also see how we can also pick output as the type as well. So we learned these 3 things in the new model. Make sure to save your model and let me know if you have any question, guys. Do you have any question? Sure. Any other question, guys?
Yeah, I have a question, Professor.
Yeah.
Yeah, I mean, currently we split the, we have 2 shifts now, but I didn't see, how can I specify the order for these 2 shifts?
That is shift 1 and shift 2. So
yeah.
When you go to the schedule, here, you can change the order here. So if you want the first one to be the first shift is the one that has 2 resources, you can specify that as the first one, I believe. Let me see if you do control of, so here, if you do pick, for example, I want to say the first shift. So if I have it this way, that means the first shift, the first 8 hours will have 2 resources. The second shift, the second 8 hours will have 1 resource. Okay. So if, let's say, I want to change it, I want to say the first shift has 1 resource, right? So you can click on the first on this one and then hold Control and then press on the arrows up. You see the 4 keys we have for the up, down, right, left, those arrows. Yeah. Use the up arrow and then press that, and then this will go up. So you can use this anyway, always. When we get to this part and we define a bunch of the things, and for whatever reason we want to change their order, we can always keep the Control and press play with the up and down button and move here. So here, if you want the first shift to be the one with 2 resources, you can do that here, and then the second shift will be the one with the 1 entity. Was that your question?
Yes. Okay. Thank you.
Yeah. So the first shift will be the one with 1 resource and said entity.
Thank you.
Question?